Good morning, Algebra 2, Period 3 class. We're going to go over Lesson 8.4a, Guided Practice Problems, Graph Equation of Ellipses. So I'm going to give you some background, and you do not need to write this down. This is just so you can begin to understand what an ellipse is, what the equation looks like for an ellipse, and how it all works. An ellipse is the set of all points such that the sum of the distances between P and two fixed points called the foci is constant. So what we're going to imagine is that we're going to take a string and we're going to pin it down here at these two focus points, and then we're going to take our pencil and we're going to put it here, and then we're going to drag it all the way around this ellipse here so that this string here, this length, stays constant. So I have a video that I've posted separately where you can see this in action, and I am going to want you at some point to take a look at that video. It'll really help you understand how that D1 plus D2 dragged around those focus points will create the ellipse that you see here. Okay, so this is where I'm asking you to watch that very short video. It's less than a minute. It's also posted in your Google Classroom for today's work. Some more background, you don't need to write this down. I'm just showing you why in an ellipse that we have the relationship c squared equals a squared minus b squared. This will be important as we begin to work out problems that we understand that relationship. What I'm going to want to point out to you here is that I've drawn a very special case where we have our imaginary string here. And so this point here is going to be the point of interest because we're going to notice from here to here it's A, which is the same length as from here to here. And here's our old D1 plus D2. It's just another point on the ellipse where the length of that string would be the same as A plus A. That gives us the fact that the D1 plus D2 is in fact the same as twice the length of A. The reason that this will be important is because we're going to notice here in this special situation that we do have a right triangle, and we have b squared plus c squared is equal to a squared, our hypotenuse, which when we solve that for c squared right here, we're going to see that c squared is equal to a squared minus b squared. You don't need to write any of that down. We're going to be using that special relationship right here, c squared equals a squared minus b squared, as we work out some problems in a few minutes. This is where I would like you to start writing down your work on this lesson. So the key concept that we're going to work with is the standard form of the equation of ellipse centered at the origin. And you notice here that there's going to be two ways we're going to write the equations down. One way has the a squared underneath the x squared. The other way has the a squared underneath the y squared. And that's going to be important as we figure out how to graph these ellipses. Now, we're going to have numbers in for a squared and b squared. These are actually constants for each equation. And when this a squared number is bigger and it's underneath the x squared term, then it means that our ellipse will be a circle squashed so that it is shorter and fatter. And that's going to mean our major axis is horizontal. And I've given you the vertices and covertices. We're going to see what all that means in just a minute. Now, our circle can also be squished to create an ellipse so that instead of being fatter and skinnier, it can be squished so that it is taller and squished together at the sides. So when that happens, you notice our a squared is underneath our y squared, and so our major axis, our longer one, will be on the vertical axis. All right, so probably doesn't mean a lot to you yet until we start working out some problems, but I do want you to write these equations down. They will be important for us as we begin our work in actually graphing some of these ellipses. For guided practice 1 through 3, we're going to do the same thing for all of them. We're going to identify the vertices, the covertices, and the focus of the ellipse, and we're going to graph that ellipse. So I'm going to take you actually to the graph first so you can get an idea of what we're doing, and then we'll go back and show how we find all of that information. All right, so over here on our graph, we're going to see that we have a kind of a longer axis here. So we think of a circle as being kind of squished down, so it's fatter and a little bit shorter than it was when it was a circle. And so we're noticing here that we call those endpoints the vertex. So the plural of vertex is vertices. So in this case, it will be at negative 4, 0, and 4, 0. Where our vertices are. And we'll talk about how to get those values in a moment. Our covertices, and that's the plural for covertex, in this case will be our shorter axis, And in this case, our covertex values will be 0, 3, and 0, negative 3. So we're going to plot those points on our coordinate plane. We'll draw a kind of a squash circle through those points, and that will become our ellipse. Our focus points are always going to be inside of our ellipse, and that's where we, again, thought of pinning down a string at the ends here, and then dragging that string with a pencil all the way around to create the ellipse. So our focus points will always lie on the major axis. That will be important as we figure out where to put them. Okay, let's step through the process for how we get this graph, because the graph actually comes after you figure out information about your A, B, and C points. So first of all, we notice for this particular equation here that underneath the x squared, we have the bigger of the two numbers, 16 and 9. That means this is the x squared over a squared plus y squared over b squared equals 1 equation. The bigger number in the denominator here will always be your a squared. So we are able now to say that a squared is equal to 16, and therefore when you take the square root of 16, a is 4. That means the other number, 9, will be our b squared number. B squared is 9, and the square root of b squared is 3. So b is 3. Those are going to be the numbers for our vertices and covertices. Let's now figure out our focus numbers. That's going to come from our c squared equals a squared minus b squared relationship. This will always be true. C squared is a squared minus b squared in an ellipse. So putting in our numbers for a squared minus b squared, we have c squared equals 16 minus 9. C squared then is 7, and c then would be the square root of 7. On my calculator, I work that out to about 2.6. So use your calculators for your non-perfect squares to find out where you're going to put those values on your graph. Here I am recording then what I just found out, what the vertices are, and the covertices, and the focus. I have to know where to put the 0 in the x or the y coordinate. Well, my vertices are going to be on the major axis, and in this case, that would be the horizontal axis, because that was where the bigger number was underneath the x squared. So on the x-axis, the y-coordinate has to be 0. So that's how I know my vertices are at 4, 0, negative 4, 0. The vertices will always be the a number, and then there will be a 0 in the other coordinate. If the major axis is horizontal, you'll have a 0 in the y-coordinate. If your major axis is vertical, your 0 will be in the x-coordinate. Now our covertices will be on the shorter axis. Well, in this case, that's the vertical axis. So based on our b number, we would have ordered pairs of 0, 3, and 0, negative 3 for our covertices. Our focus points are going to lie on the major axis. So notice here that where the zeros are in the vertices matches where the zeros are in the focus. The focus is always on the major axis. This time it's the horizontal axis. Then I plot all those points. Now after I plotted those points and drew my ellipse, I did use thinking bubbles to identify which one was the focus, which was the vertex, which was the covertex. You don't have to write those down, but it might be helpful so you can get this all sorted out since this is a new process for you. Guided practice 2. So we're going to take a look at the graph that you're going to end up making, but you can't make it until you identify your A, B, and C numbers. So again, this is kind of a squash circle. It almost looks circular, but this time notice that our vertical axis here is a little bit longer than our horizontal axis, because our vertical axis goes up as high as 7 and down as low as 7, and our minor axis here, our x-axis, our horizontal axis, only goes as far to the right as 6 and to the left as far as negative 6. All right, so how do we get our numbers this time? Well, we notice that underneath the y squared, that 49 is bigger than the number underneath the x squared. So this time the major axis is vertical because the bigger number is underneath the y squared. So that means our a squared it's always going to be the bigger number, is 49, and the square root of 49 is 7. B squared is 36. It's underneath the x squared this time, and so that means b is 6. Then we plug into c squared equals a squared minus b squared to get 49 minus 36, and then our c squared is 13. Finally, our c then will be the square root of 13, and on my calculator, I see that's approximately 3.6. At this point, I'm ready to write down my vertices, my covertices, and my focus. My vertices are on the vertical axis this time. That's why you see 0 in the x-coordinate, because on the y-axis, the x-coordinate is always 0. So my vertices are at 0, 7, and 0, negative 7. My covertices, of course, will be on the other axis. In this case, it is the x-axis, the horizontal axis. So my covertices are 6, 0, and negative 6, 0. My focus will lie on the major axis, which in this case is the vertical axis. That's why you see zeros for x coordinates. So my focus is at 0, root 13, and 0, negative root 13. Notice on my graph here, I actually put the approximation for the values of the square root of 13 to make sense of where is that focus. The focus is always inside of your ellipse, and the focus points are always on the major axis, the longer axis. In this case, the vertical axis. Okay, last one will be similar to the other ones with one added step. Guided practice 3, we have 25x squared plus 9y squared equals 225. And we're saying, wait a minute, we're not equal to 1. How can that be the equation of an ellipse? Well, our first step is to get into standard form of an ellipse equation by dividing by 225 on all terms in the equation. That gets us into standard form of an ellipse equation, x squared plus 9 plus y squared over 25 equals 1. Now we proceed just like we did on guided practice 1 and 2. This one will be more similar to guided practice 2 since we have a vertical major axis. And we know that this is a vertical major axis because 25, the bigger of these two numbers, is underneath the y squared. And remember, the y-axis is the vertical axis. So the 9 then corresponds to your x-axis. This is going to be the minor or the shorter axis. All right, so let's go ahead and get our numbers. So a squared is 25. It's always the bigger number for your a squared. Square root of a squared is 5. B squared is 9. That will always be the smaller number, and in this case, it will be on the horizontal axis. B is 3. Then plug into c squared equals a squared minus b squared to get your c value for your focus. So we're going to have 25 minus 9 equals to c squared. C squared then would be 16. And this time we have a perfect square situation. No calculator is needed. C is equal to 4. Okay, now we're ready to write our vertices, covertices, and focus. Again, to know where those zeros are, we ask ourselves, well, which is the major axis? Well, this time it's the vertical axis, and the vertical axis lies on the y-axis, and on the y-axis our x-coordinates are always 0. That means our covertices lie on the x-axis, and on the x-axis our y-coordinates are always 0. And we're pulling the 5, negative 5, 3, and negative 3 from the information that we worked out up here. Our focus, which will lie on the major axis, which in this case is the vertical axis, our focus based on our c value here is c 0, 4, and 0, negative 4. We're going to plot all of these points on our coordinate plane, and we'll draw an ellipse through those points as best we can. This is not art class, so you have to forgive my ellipse for not being perfect as well. And of course, the focus points are going to lie on that major axis, which is the vertical axis in this particular problem. So here I have my focus points inside, labeled as 0, 4, and 0, negative 4. Again, I've used thinking bubbles to label all of those ordered pairs that I plotted just to begin to understand how this process works. It's not required to write that information, but it might be helpful for you. That concludes our guided practice problems for this lesson, so it's time for you to start working on the homework and have it ready for next time. See you then.